Okay, so this is bivariate regression, week 12. To make it very simple, statistics, remember, is about relationships between two things. Regression is no different. The only thing we're looking at with regression is the strength of a relationship, the direction and the strength of a relationship. So when you see regression, it's a little misleading because it makes you think that it's more complicated than it is, but all we're really doing is we're now plotting and looking at the relationships between variables. So, bivariate regression, here is week 12's data example that the professor emailed out. So I'm going to start with this to explain it. So obviously bivariate, we're only dealing with two variables this time, the independent and the dependent. In this case, performance-related pay is a percentage of salary and the number of overtime hours per week. Basically, overtime is our dependent variable, and our hypothesis is that PRP affects the number of overtime per week. Okay, again, we have to prove our hypothesis. We have to prove that there is a cause and effect here. So, the first part of regression, unlike the other statistical analyses that we've been doing, is that he does want us to use a scatter plot because we need to visualize what's going on between the two variables first. Okay, why is this important? Because the scatter plot tells us a couple things. The first thing the scatter plot tells us is we can visually determine where our observations fall with regard to the regression line. And all the regression line is just an arbitrary line, the best fitting line through all the different observations. It's a lot like a mean or an average. It doesn't necessarily represent every single observation honestly, but it's just the middle road. It's the best fitting line through all the observations. So for example, this scatter plot, and I'll get to how you do a scatter plot. Once you develop your scatter plot, a couple things you're going to see. So obviously you need to label your scatter plot. Here's your y-axis, so it's your dependent variable. Here's your x-axis, so it's your independent variable. We can visually see where our observations fall. Okay, we can also see the regression line, or your best fitting line, through the observations. And as you can see, not every observation is going to be as close to this regression line because they each have different relationships. You know, remember, we're looking at individual employees and their individual instances of overtime and PRP. Okay, so just looking at our scatter plot, we can tell that it's a positive relationship because it goes up with each observation. We can also see that it's a good fitting line because of where the observations fall around the line. There's no wonky pattern. We'll get to that in multiple regression. There's no wonky pattern around the line. So this is a good example. When you do the scatter plot, it's going to automatically include formulas, okay? And to click on that, our formulas, first of all, the formula in the PowerPoint and the formula that the scatter plot puts up are backwards. So, for example, in the PowerPoint, let me get to it. In the PowerPoint, the formula is, I'll write it down. The formula is y equals a plus b times x plus e. All right, make this really simple. Basically, okay, your a right here is your y-intercept when x is 0. So if we expanded this scatter plot, we would see, okay, as we move the line down, we go into a different quadrant, we would see the line hit on a negative number on the y-axis, right? Okay, b is our slope, is the change. 1 unit in x, 1 unit in y, 1 unit in x, 1 unit in y. This is our slope. The slope is also the coefficient when we run regression. I'll get to that. Okay? Your E is your error term. An error term is really simple to understand. You see this space between this observation and the line, your error term is the sum of all of these spaces between each observation and the best fitting line. That is all the error term is. Okay? So again, your A is your intercept when your y-intercept when x is 0. Okay? Your B is your slope, rise over run. Okay? Which is times your x variable here, your x, whatever x is on the line at that point, plus the error term. Now, don't worry so much about the error term. You just need to know that you need to include it in the equation, that it's there. You don't even have to put a number for error term. You just have to write plus error term. Okay, back to the scatter plot. The thing is with Excel is that they reverse it. So in this case, our A, or our y-intercept, is a negative number, which makes sense because if we expanded y down and we move this line down, it's going to hit in the negative quadrant. Okay, so this is actually A, so it's a negative number. And then that is our slope, is our rise over run. Now, how do we know that that is correct? We know it's correct, number one, because it is a positive number. We don't see a negative, we don't see a minus sign before the number. Okay, we also know it because it's next to x. So it's pretty clear that that's our slope and or our coefficient. In this particular assignment, when you see slope, it's coefficient. When you see coefficient, it's slope. Okay, the scatter plot also gives us our r squared. And really all our, all our r squared is, it has to do with model fit. And what's model fit? We are now visually looking at the relationship between variables. This is where our Venn diagram comes in. And if we drew out a Venn diagram, okay, we would see an overlap between PRP and overtime, right? The r squared really just has to do with the fit of the model. How well does our overall modeling of the relationship fit together? Okay, let me get to that part so I can explain it better. Okay, in this case, we have an r square of 93.93. So really that's 93% overlap, okay? And basically r squared is the explained change in y by knowing the change in x, okay? We know the two variables overlap, and that's how they interact, and that's how a relationship is built between them. So we're just looking at the relationship between these two variables. And the r squared tells us that the relationship between overtime and PRP, taking all observations into account, there's a 93% overlap, okay? Now, to run regression, all you need to do is this. You have your variables, like so, data analysis, regression, hit OK. You're inputting your Y range, which is hours of overtime per week. You're going to put your X range, which is PRP. Click it. We're including labels. Let me get to that. Okay. We want to keep a confidence interval of 95%. All that really has to do is our p-value. We want it to come up with p-values of 0.05. All right. Output range. And you can just click that anywhere you want. Okay. You could also do residual plots. I'll show it to you. You don't necessarily have to do it, but I'll show you why you would want to do it. And you hit OK. And there we go. Okay, so we got to clean up our information first. So first things first, we have to take out ANOVA. Okay, we want to take out our duplicated lower and upper 95% because there's kind of no point for that. Okay, here we're highlighting R square. Remember, this is bivariate regression, so we're only highlighting R square. When you see coefficients, again, that's slope. So we want to look at the relationship of PRP. Okay. If we look here, you see this intercept here? Remember, our intercept is basically where they meet here, okay, on the x line. When x is 0, where does y start? Okay, we're looking at our t-stat, and we're looking at our p-value. Now, if you get a wonky value here with your p-value, all you have to do is go back to home, number, go to number on the side, and hit OK. And it'll turn it into a number, and then I would expand it out. Okay. As usual, highlight all your numbers. Bring them back to the second decimal point just so it's easier for you to read. So, what do these things show you? Okay, we'll make it really easy. All right, remember, our coefficient right here, we know where our intercept is. Where does y fall when x is 0? We know it's in the negative just from the direction of the plot. Okay. All right. Right here, coefficient, PRP in percent of salary. This is our slope. Okay, this is our coefficient, this is our slope. And that has to do, again, with rise over run. We go back to our scatter plot. So 1 unit of x, 1 unit of y. 1 unit of x, 1 unit of y. Okay. Now, just like we did in a correlation matrix, what are we looking for here? We're looking for the strength and we're looking for the direction. Okay. Before we even get into that, though, we have to go back to our t-stat and we have to go back to our p-value. Okay, automatically we see our p-value is very small. It's less than 1%. So that tells us that we can have faith in the t-statistic, that we can trust what this number is telling us. Remember, we always want t and p values to be opposite. We want t to be large and p to be small in order to reject the null hypothesis. Basically, the hypothesis saying that there is no correlation change relationship between two variables, which gives us evidence for our alternative hypothesis that there is a correlation or a relationship between two variables. P-value is small, t-stat is very large, it's well into the tails. Now, go into your coefficient. Now that we've established we can trust the numbers we're looking at based on the p-value, and that it's significant because it's in the tails, let's look at our slope. We're looking at our coefficient. And what does this tell us? This tells us that for every unit, hold on, let me get back to it. Okay, we didn't get into that. I'll have to explain that next video. Basically, we know it's a positive relationship, which we saw in our scatter plot. We know it's a strong relationship because it's over. Remember, coefficients are read as weak, moderate, strong, or perfect. This is clearly strong or moderate. It might be on the high end of moderate, low end of strong. But it's a positive, strong relationship between PRP and overtime. Okay? So you could say, I believe, that for every 1 unit of PRP, every 1% of PRP, overtime goes up by 0.79 an hour. Don't quote me on that, I'm pretty sure. Now, the residual plots you don't have to worry about, but this is just to give you an idea of this is just quantifying what you're seeing up here. These changes, these are your error terms. You don't really have to worry about that because the computer does it for you, but it's just so you understand if you do click that, that's what those dots represent, these numbers, okay? In terms of doing a scatter plot, that's pretty easy. All you do, go over here, you highlight your 2, okay? Insert, go up to insert. We're going to go to scatter plot, okay? You see what I'm doing here? Now you can move this. My phone's going off in the back, I'm sorry. Okay, we want to label it, so we're going to go to format chart area, layout. Okay, you go to layout, chart axis titles, primary horizontal title. So that's our x-axis. So that's going to be our PRP. Wait, where's it going? Okay. We also want to add vertical, which is our Y. Okay, this is overtime. Okay, so we've labeled it. All right, now let's say you want to add your regression line, right? Click, all right, okay, you would click on any one of these dots. Okay. Where is it? We want to... You right click and you go add trend line. Okay, it'll be linear, display equation, display R squared value on chart. Okay, close, and there you go. You can move this over here. I would. Okay, and this gives you the best fitting line, and we can test it because if we look again, remember, Excel does it backwards. If we look at our A or our y-intercept, we know that it's negative. Okay? If we look at our slope or our coefficient, we know it's positive, which matches with the trend of the data. Okay? Our R squared is the amount of overlap between overtime and PRP, which we can trust because of our numbers up here. Okay? So that's all you really need to do. The only other thing I would tell you to do is you can change the format trend line. I like to change the color, just so it doesn't get in the way of you interpreting where the observations are and where the trend line is, and it's very easy to see. That's the only other thing. He didn't require it, but that's what I would recommend. So that is how you create a scatter plot. You run regression, and you read your regression, okay? And that is Bivariate regression.